Hello children, hi to everyone. So this is myself Umesham and welcome to your channel, that is Physics by Imagination. In this class we will understand about magnetic effects of electric current. So I have written so many things, so you should learn so many things now. Let us learn without wasting of time. The first one is that magnetic effect of current. As we know that what is electric current? The rate of flow of electric charges is called electric current. So electric current is going to produce magnetic field, that is called a magnetic effect of current. It's very simple. Whenever we pass the current through the wire, around that it is going to produce magnetic field. It is going to take you now. That is called magnetic field, attraction of force. So this is first explained by whom? That is Oersted effect. So it tells that whenever current carrying conductor produces magnetic field around the current, that is called Oersted effect. If length increases, that is attraction will decrease. If length decreases, attraction will increase. Second one, magnetic field and magnetic field lines. So what is magnetic field? Suppose if I take a magnet, around this there is a presence of certain amount of force. You take some iron fillings and put on this, what is going to happen? The iron fillings or iron pieces are going to be attracted by this magnet. So why it has attracted? Because there is a orientation of electrons that is going to cause magnetic field. So now here what is magnetic field means? When the charge is at rest position, it is going to have electric field. Now when the charge is at motion, it is going to produce magnetic field. So what is my point here? What is magnetic field means? The region surrounded by the magnet or of a moving charge experiences a kind of force, that is like poles, north north, south south, repulsive. Unlike poles, north south, south north, attractive. So this is about magnetic field. Next, magnetic field lines. These are imaginary lines which are present surround the magnet, are called magnetic field lines. Okay, so next, and they move from north to south direction. That's it. These are the imaginary lines. They move from north to south direction in the magnetic field, are called magnetic field lines. Next, properties of magnetic field lines. That is, inside the magnet they move from south to north. First point over. Outside, north to south. They start at north, end at south. Inside, start at south, end at north. So third point, they are closed loops. They are closed loops. Fourth point, they are always tangent to the magnet. Fifth point, they do not intersect together. I mean, they never and ever intersect together. Why? Because if they intersect at the same point, suppose you take north, this is south. If they intersect like this, at the same point, we have to see two directions, which is highly impossible. Hence, we can't find that is two magnetic field lines ever and never intersect each other. Afterwards, we are going to come to the point, last but not least, the strength of the magnetic field depends upon number of magnetic field lines and distance between the magnetic field lines. Suppose children, I am going to draw like this. So this is big one, distance is more, so strength of the magnetic field is less. If distance is less and number of lines are more, then what is going to happen, children? That is, magnetic field will be more in A compared to B. So the last property of the magnetic field lines is nothing but the strength of the magnetic field depends upon number of lines and distance between them. So what is first point? Inside they move from south to north, outside north to south. Third one, they are closed loops. Fourth one, they do not intersect together. Fifth one, they are always tangent to the magnet. Sixth one, the strength of the magnetic field depends upon number of magnetic field lines and distance between them. Next, I come to the point, magnetic field due to a straight current carrying conductor, circular loop, solenoid. Just focus what I am telling, children. Now here, a straight carrying conductor. Let us imagine a conductor. Okay, so it is going to carry current. Then already what Oersted told us, the current carrying conductor produces magnetic field. So if I put some iron pieces or fillings, then they are going to form encircled way. So this means the current is going to produce magnetic field according to Oersted effect. Okay, now this magnetic field, how can we increase? Just if I increase amount of current in this wire, magnetic field increase. That's it. Second, circular loop. If I increase number of wires, I have made in the form of loop, connected to battery, again plug key. You should imagine the things. Then I am going to pass the current, produces more magnetic field compared to previous one. Then what is going to happen here? How can we increase this magnetic field? That is NEA. NEA means what, children? Number of turns of the coil, that is amount of electric current, area of coil. This magnetic field can be enriched or increased by increasing number of turns in the loop, by increasing passing of amount of current in the loop, by increasing area of the coil. Over. Next, solenoid. What is solenoid? It is as if like a magnet. If you know that, this is gift. Now, what is solenoid? It is an insulator. It do not conduct the electric current, and that is coated by large number of copper turns and produces uniform magnetic field. Is called solenoid. It is an insulator which is surrounded by large number of copper turns. Means the whole conductor is coated by copper turns and produces a magnetic field. So properties are same thing as if what we are going to see here. First one is from inside south to north, outside north to south. They are closed loop. They are tangent to the magnet. They do not intersect together. Number of the strength of the magnetic field depends upon number of magnetic field lines and distance between them. So after this, we are coming to motor and generator. So dear children, what is motor? So very simple. Motor, generator. If I switch on the fan, what is going to happen? That converts energy from electrical energy into mechanical energy. So you have to focus here, very important about this. We can expect one MCQ. So what is motor? The device which converts electrical energy into mechanical energy, that is called a motor. Generator, reverse. You might be seen in olden bicycles. The device which converts, when you go on pedal the bicycle, pedaling, then that is going to generate electric current. So motor means the device which converts electrical energy into mechanical energy, and generator means mechanical into electrical energy. Means mechanical means something is going to be moved. So now we understood definitions. Come to that is rules and principles. Very important, children. Definitely there are chances for that to ask. That is, rule used in motor is FLH, that is Fleming's left hand rule. Rule used in generator is that is FRH, Fleming's right hand rule. We'll understand in this after 2 minutes. So before that, principle used in motor and generator. Imagine children, this is a north pole, this is a south pole, and this is conductor. Then I passed current through this, then this is going to experience a mechanical force. So what is the principle of motor means? When our current carrying conductor kept between the magnetic field, then the conductor experiences a mechanical force, that is called principle of motor. Principle of generator, EMI, that is electromagnetic induction. What is electromagnetic induction? We'll understand, and also we'll understand simultaneously what is about Michael Faraday's experiment. So very simple. He thought, actually what Orested told children, where is a electric current, there will be a magnetic field. He thought reverse, where is a magnetic field, there will be a current, and got Nobel Prize. Now he took a bar magnet and a hollow tube that is coated with copper tons connected to galvanometer. Over. This is the construction part of Michael Faraday's experiment. Now working. Take the magnet, push inside the coil. There is an interaction. Then when there is an interaction between this magnet and coil, then electrons will start to move and produces current that measured by galvanometer, and this current we call that EMF, that is electromotive force. Electromotive force, or we can call induced current. So I am coming to this point. What is the principle of generator? That is EMI, electromagnetic induction, the process of producing induced current or electromotive force by changing magnetic field is called electromagnetic induction. That much only. Next, here cases are there. First one, I am going to take the magnet, I push inside the coil. There will be interaction. Hence current will produce, but deflection will show towards the left direction. Okay, and that current is measured by galvanometer. It is a device used to find small amount of current. Later on, I take it outside. Interaction, deflection will towards right, opposite direction. If I push front side, deflection will be opposite. Then current is moving in opposite direction. Third case, and I am going to maintain stationary. Coil is here, magnet is here. Can we produce any kind of electric current? No, because there is no interaction between the magnetic field and the coil. Hence, no current, no deflection. If I increase speed of the magnet, it generates more amount of current. So children, very important point, listen here. They'll ask you definitely in the examination. Here, how can we increase magnetic field? By increasing number of turns of the coil, by increasing amount of passing current in the coil, and by increasing area of the coil. Here, how can we increase EMF? Or how can we increase electromotive force? That is, by increasing number of turns of the coil, by increasing area of the coil, by increasing strength of the magnet. Strength of the magnet should be increased. Next, by increasing speed of the magnet. So this is about Michael Faraday's experiment. Now let us come back to here. FLH, FRH. Fleming's left hand rule. Let us understand first Fleming's right hand rule. All of you old children like this. Then what is going to happen? So this is the conductor. When I push like this, so I am going to push like this. Then it tells that when we hold like this, the three fingers of the right hand mutually perpendicular to each other. The angle between each finger is 90 degree. Then this tells that motion of the conductor. This forefinger tells that direction of the magnetic field. Middle finger indicates that direction of the induced current or electromotive force. Very, very important point. So that it is induced current, magnetic field, motion of the conductor. This is over. That is rule used in the generator. Come to the point. Solenoid. So use it like this. Left hand. So same thing, whenever we are going to use the first three fingers of the left hand mutually perpendicular to each other, then this is mechanical force, this is magnetic field, and this is amount of electric current. Left hand only current, here II, induced current. So this is all about motor, generator, Michael Faraday's experiment. So we discussed the definitions, principles, rules, and he may ask you some important functions. Example, slip rings, split rings, slip rings, split rings, carbon brushes. Very important functions. Slip rings are going to change. Slipping, the current will change both positive and negative cycle way. Okay, that is going to produce AC in the case of generator. Also in the case of Michael Faraday's experiment. So slip rings are going to change direction of the current in both positive and negative way. Split, cutting. Okay, so split rings are also called as commutator. So that is going to move the current either only in positive direction or in negative direction. Carbon brushes, they connect the current to the external circuit. Over. Let us come to the point, two coil experiment. As the name itself, it is telling that it consists of two coil, coil 1 and coil 2. Okay, so now what is going to happen? You connect the battery through the coil 1 through plug key. Now current is produced. Around this magnetic field is present. Then again coil 2, here we are not passing current. So here current is there, around this magnetic field is there. This magnetic field is going to generate current in the beside coil. That is called MI. MI means what, children? Mutual induction. The process of producing current in another coil, change of current in one coil. That is called mutual induction. Or you can tell that the process of producing EMF in another coil by changing current in one coil. That is called, so hence the name two coil experiment. If I switch off the battery, so consequently the current will become 0 in the coil 2. Here also we are going to use Fleming's right hand rule. Here left hand rule. Next, last but not least, that is mechanical force experienced by the current carrying conductor. Very simple. Let us consider a stand and a wire is connected to two terminals of the battery through plug key. Then here there is a presence of aluminum piece. Imagine this is the aluminum piece. Now I switched on battery. Current is moving, electrons are moving here. Then around this aluminum piece, what is present? Magnetic field. Then I am going to take horseshoe magnet. I'll keep it here. Already surrounding this there is a presence of magnetic field. This magnetic field moved towards left, upwards like this. Did it push? Did you push? No. So that it experiences the mechanical force. That is the principle of motor. The current carrying conductor experiences a mechanical force when it is kept in the magnetic field. So this is all about mechanical force due to current carrying conductor. Dear children, we have covered all the things in Michael Faraday's experiment. That is everything in magnetic effect of current. So I hope you understood. If you like the video, please share and subscribe. Thank you.